Hi there! We are to solve this another given system. This is still a system of linear equations into two variables because we have here the variables x and y, two of them, and both of them have exponents of 1. That's why they are still called linear. Now, for any linear system just like this, you can use the graphing method. You graph because both equations here, their graph are lines. Okay, so if we're going to graph their lines, and if there is an intersection, that said intersection is the solution. If there's no intersection, then there is no solution. So here we are going to use another method, and we're going to use here the elimination method. By the way, you could also use the substitution method, but I chose here to use the elimination method. So we have here 4x plus 3y equals 2, and then 2x plus 5y equals 8. We are going to choose a certain variable x that we are going to eliminate, and then not variable x, but in this case I will be using x, but we are going to use here a certain variable that we are going to eliminate to solve the other, and whatever the value of that other variable, we are going to use it to solve for the first variable that we have eliminated. As declared already earlier, I'm going to eliminate here x. The reason for that is very simple. If we're going to look at the coefficients of x, the coefficients are multiples, one of which is multiple of the other. We have 4x for the first equation and 2x for the second equation. So I could make it easier. I could apply an easier process in eliminating x as a variable because 4 is a multiple of 2. Let me rewrite first the equations before I will demonstrate how it's done. So the equation here, first equation is 4x plus 3y equals 2. Our second equation is 2x plus 5y is equal to 8. So by elimination method, again, we are going to eliminate a certain variable, but we are going to apply a certain constant through the process of multiplication in a certain equation, solve that later, and we can eliminate such. Because when you say elimination method, we are going to add the two equations and making sure that one of which is really going to be eliminated. So we're going to add the two equations. I'm talking about this one here. I'm going to multiply the second equation with a negative number, specifically negative 2. Once I will multiply negative 2 to your x coefficient of 2, so it will become negative 4. So the first coefficient of x in our first equation is 4x, and what will happen to the second equation? It will become negative 4x. Hence, it will become eliminated once added. Okay. But don't forget, if you're going to do this, the said scalar or constant will be multiplied as well to the entire coefficients. So this would be equivalent to this one here. Okay, so the first equation is still 4x plus 3y equals 2. Your second equation, negative 2 times 2x, you have negative 4x. But make sure that you're also going to multiply negative 2 to 5y and to 8. So I have here negative 2 plus 5y is minus 10y. And negative 2 times 8 in your constant in your right hand side, you will have here negative 16. So don't worry about multiplying a certain constant. Once you do it right, it's just a multiple of the said equation. You will have the same what do you call this one, slope of a line. Okay, so with this we can now add them and then cancel out 4x and negative 4x, leaving y. That's the first variable that you can solve now. So we have it here, y. So positive 3y minus 10y, I have negative 7y is equal to the other side. 2 minus 16 is negative 14. So y, when dividing both sides by negative 7, you will have positive 2. This is not a variable for your value for the variable y. Okay, but if you are not convinced, you also have a way to check this one. This value of y is acceptable and it's true if you're going to substitute this to both of the equations. It should satisfy the it should get the same value of x. If it will not get the same value of x, then there's something wrong in the process, and probably the value of y that you have solved is incorrect. Let's start it with the first equation. Our first equation is given as 4x plus 3y is equal to 2. Let's substitute y as 2. So you have 4x plus 3 times 2 equals 2. 4x plus 6 equals 2. And then, of course, you apply the necessary processes. We'll have negative 4 because you subtract both sides by 6. And then x is negative 1. Okay? That's the value of x. But again, of course, if you're too confident with your answer, then you might stick with this. But for me, I also would like to check the same value of y to the second equation, and if I will get the same value of x, then that's the final solution. But when you substitute, by the way, for the second equation, when you substitute y as 2 to the second equation, here it is. Use the original equation. Do not use the negative 4x minus 10y equals negative 16, which is the result when you multiply negative 2 to your second equation. Well, you may, but the point here is this. What if in the process of multiplying negative 2 to your second equation, one of the coefficients is incorrect? Even if you will substitute the same value of y to that version of the second equation and it will get the same value of x, it's not a guarantee that your y and x later on are correct. Okay, so substitute the value of y in this case to the original equation, second equation, and you could see there that if it meets the criteria, then automatically you are 100% sure that it's correct. So the second original equation is 2x plus 5y equals 8. So you have here 2x plus 5 times 2 equals 8. You have 2x plus 10 equals 8. You subtract both sides by 10. 2x is equal to negative 2 and x is negative 1. Now this is now the guarantee that I have mentioned earlier. In short, you are now sure that the value of y that you have solved earlier is correct because it resulted to the same value of x, which is negative 1. This means our solution is a point on a Cartesian plane having the coordinates negative 1 for x and 2 for y. Or in this case, you can use here this form, point. Okay? You have negative 1 and 2. So you start with x and then you have your y. This is the solution for this given linear system. Now, we will proceed further because we would like to make sure that our answer is correct. So we can check whether our solution is correct, as this point should satisfy both equations. So this is now the checking. We have negative 1 for x and y, which is 2. Our original equation is this, 4. Okay, 4x plus 3y equals 2. So once I will substitute negative 1 here and 2 here, I'll be placing question mark because I'm still checking. The goal of checking is to make sure that both sides of the equations will have the same result. Even if it's too obvious, just simply continue with the process. Negative 4 plus 6 question mark 2. So you have 2, 2. Once you reach this, check. It satisfies the first equation. Now let's look at the second equation. Again, original equation. 2x plus 5y is equal to 8. 2 times negative 1 plus 5 times 2, question mark 8. Negative 2 plus 10, question mark 8. You will have here 8 is equal to 8. It also satisfied the second equation. So this solution that we have presented earlier is really the solution for this given linear system. And if you're going to draw the representative line of the two equations, the two lines will intersect at a point negative 1 and 2. Thank you very much for watching.